Hi everybody, it's August 4th, about 80 degrees outside in this beautiful, beautiful summer day. Just wanted to touch base with you, and I want to talk about the globers, the ballers, the anti-flat earthers belief system. Maybe, have a little conversation about it. Poke a little fun where fun needs to be poked. Anyway, number one. The Earth spins at 1,037 miles per hour at the equator. 1,037 miles an hour at the equator. Now, if you're up about the 40th latitude, then it only spins about 700 miles per hour. That's cool. And it's nice that it spins. Because it gives us sunsets, and it's tilted 23.4 degrees, so we can vacation in Florida. We might get into that a little bit later. Anyway, cool story, bro. If you don't get this by now, the fairy tale globe is scientifically impossible. So we'll just call it a fairy tale globe. There's no if globe. Globe doesn't exist. There's no globe theory. There's no theory. There's no globe. So it's fairy tale globe or globe fairy tale, whatever you want to call it. Number two, the Earth travels around the sun in an elliptical orbit. The reason it travels around the sun in an elliptical orbit is in the math. A circular orbit doesn't work. So they had to make it an elliptical orbit. They never observed it or measured it, but it has to work in the math, right? So, in an elliptical orbit, because the circular orbit doesn't work, at 30 kilometers per second, or prepare yourself, 66,600 miles per hour. 666. Darn those spiritual Christian people. They just bring up 666. It's just like, why? Because it's pretty much everywhere in your fairy tale globe. 30 kilometers per second, even though Michelson, Morley, Dayton, Miller, every interferometer experiment ever done has never shown more than 3, 5, 6, or 8 kilometers per second, we'll have it at 30 kilometers per second. Why? Because Google says so. Cool. Number 3. The Earth travels around the Milky Way galaxy at 450,000 miles per hour. You know what I've seen about these numbers is they're so crazy, people believe them. People would rather believe a big lie than a little lie, and if you tell the big lie often enough, sooner or later people will come to believe it. These aren't just big lies and, huge lies, humongous lies. These are lies that maybe only Satan would tell. Anyway. Wow. Number 4. The Earth travels throughout an ever-expanding universe at 1.3 million miles per hour. 1,300,000 miles per hour. I mean, what are you going to do, man? What are you going to do with the fairy tale? I mean, tuck me in, give me some warm milk, give me my blankie, give me some soft music, give me my fan, it keeps me cool, and tell me a bedtime story, man. I'd rather believe in Santa Claus and the Easter Bunny than believe in this stuff. This stuff's nuts, man. Anyway, number 5. The ever-expanding universe expands, or redshifts. Redshift. At 4 times the speed of light. 4 times the speed of light. Light is 186,200 miles per second. In their fairy tale, what Einstein said was constant. And we're told that the universe is somewhere between 28 billion light years and 200 billion light years long. So, to be 4 times the speed of light, you have to know what the size of the universe is, because the smaller the size, the less it's going to be redshifting at the outer limits. The bigger the universe, the more it's going to be redshifting at the outer limits. So what is that 4 miles per second, 4 times the speed of light based off of 28 billion, 50 billion, 100 billion, 150, or 100 billion light years in their fairy tale. What's it based off of? I don't know. Makes for a good story. Oh, it makes for a good bedtime story, I should say. And it gets even better. The Andromeda Galaxy, which is right next to our Milky Way galaxy, in their fairy tale, is blue shifting. It's moving toward us. Not moving away from us. It's moving toward us. And in 2 billion years, with a B, it will collide with the Milky Way galaxy. But don't worry. Don't worry, be happy. Because both galaxies are so expansive and there's so much space, nothing's going to hit each other. More than likely. Nothing's going to hit each other. But hey, makes for a great story, man. Hope my milk's warm. I hope whoever makes it for me makes it nice and warm for my bedtime story. Anyway, number 6. Large bodies of water at rest bend around your fairy tale globe. So, we have water. Here's water. Unless I shake it, it pretty much finds its level. Level? Not spherical level, Globers. You guys are so funny, man. Level. But we're told that if it goes out this way about 2 miles and goes out this way about 2 miles where we can't see it anymore, it starts to bend. Cool. I like my bendy water. Goes with my Bud Light. Cool. Bendy water, Bud Light. 4% alcohol content down the street. Go get some. Anyway. Moving on. Number 7. Light curves to confirm your ball, or to make your ball work, your oscillating spheroid, oblate spheroid, sphere, planet, globe, I don't care. It's all fairy tale anyway, so I don't care what you call it. So, in physics, gravity causes light to bend towards the ball. And then, supposedly, light will bend towards the ball because of refraction or atmospherics, which totally goes against the physics of light, but who cares? It's a ball, right? We got to have our ball. It's the ultimate in begging the question fallacy. It's a ball because it has to be a ball. Hey, if it has to be, it is. I don't want to take away your ball, man. Number 8, the second law of thermodynamics doesn't apply. Gas pressure without a container. So if you have a high pressure system and you have a no pressure system, 10 to the negative 17 torr, most we've ever been able to measure here on Earth is 10 to the negative 6 torr. So let's just make a fairy tale outer space 10 to the negative 17 torr, which is 11 more zeros. 12 zeros is a trillion. So 11 more zeros. And forget the second law of thermodynamics. Gravity holds things down. And so you got this big force that wants to push everything out into outer space, the fairy tale outer space, which would kill you because you'd have nothing to breathe, but gravity keeps you alive. I like gravity. If it wasn't for gravity, we'd all be dead, man. Too bad gravity doesn't exist either. Anyway, number 9. Newton's third law of motion doesn't apply to outer space. Here on Earth, terrestrially, it works just fine. You have submarine going through the water pushing back against it, airplane going through the air pushing back against it, swimmer swimming, water pushing back against the swimmer. You have your car and going forward, and you have the pavement, maybe a little bit of wind pushing back against it. But if you picked your car up like the Jetsons from 50, 60 years ago and tried to move, there's nothing to push off of. So where you go, man? You go to outer space, and then it works in outer space. Cool. I like it. I like it. So Newton's third law of motion. For every reaction going this way, there's an opposite reaction going the other way. And in outer space too, where there's can be no ignition because there's no air, and there can be no propulsion because there's nothing to push off of, but they take it with them. Cool. I like it. It explains a Star Trek episode for me when they go warp 7. But again, Globers live in a Star Trek episode, so hey, good for them. Okay, the inverse square law of light doesn't apply either in the Globers belief system. Because the inverse square law basically says if you have something that goes half the distance, the light will get 4 times brighter, and if you go the other way, you double the distance, the light becomes 4 times lighter. So, if in the fairy tale the moon is 238,000 miles away, let's call it 240,000, forgive me, 2,000 miles. What's 2,000 miles in a fairy tale, huh? And if you make that half, that's 120,000, half of that 60,000, half of that 30,000, half of that 15,000, half of that 7,500, half of that 3,750, half of that 1,875, and approximately half of that 1,000. If you got to 1,000 miles from your fairy tale moon, you would be 65,000 times brighter than it is terrestrially here on Earth. 65,000 times brighter. I didn't see that with Apollo 11, 14, 15, 16, and 17. I didn't see that with Artemis either. Kind of look like the same color. Maybe even more dull than it is terrestrially. But who cares? It's a fairy tale, man. Now, I want my milk at about 110 degrees when you bring it to me for my bedtime story. Just want you to know that. I'm very particular about the temperature of my milk for my bedtime story. So, inverse square law of light, who cares? And then, of course, looking out at Saturn, they basically tell us, NASA tells us that the sun from Saturn is about as big as this little end of the pen right here. About that big. But we can see it just fine when we look terrestrially out. Okay, whatever. It's only a fairy tale, man. So anyway, it's a belief system, fairy tale, doesn't matter. Time dilates, number 11. Oh, I tell you what, you got to have your time dilation. You got to have your pound replica. You got to have your, blue shift, red shift. You got to have your half-leak heating. You got to have your Boulder, Colorado, and then versus London with 0 sea level. Boy, I mean, you got to have a lot, man. I mean, time dilation. North Pole to the equator, difference over 100 years of age is 0.03 seconds. Oh my goodness. And then somebody ages faster at 15,000 feet elevation if they lived their whole life versus sea level. Oh my goodness, man. Time dilation at its best, man. I like time dilation. It's cool. Can't prove it, but it's cool. It sounds good. Time dilates. If you took that to a restaurant and asked your server, hey, can I have a glass of time dilation? Hey, they probably had it on the menu. Then, of course, number 12, length contracts. Length contraction, 1892. We had to make sure Michelson-Morley didn't give us a null result, so we had to length contract the apparatus and made the light going with the motion of the Earth shorter so we could have our fairy tale, something like that. And then we got mass increases. I mean, I really don't care. After time dilates and length contracts, I really don't care about mass increase. Look it up. Don't care anymore, man. Number 14. Something called gravity exists, though has never been identified or measured. We got 9.81 meters per second squared, agreed upon average of why things fall to the ground or go boom boom. And within that 9.81 meters per second squared, we have the radius of the Earth, never been measured. We have the we have the mass of the Earth, never been measured. But because we have the ultimate in begging the question fallacy that it's a globe because it has to be a globe, we assign a radius, we assign a mass, and we come up with 9.81 meters per second squared, and we call it gravity. Cool. Cool. We can't call it anything else because gravity keeps the globe together, and we got to keep our fairy tale, right? Anyway, and then 15, mass attracts mass. I mean, Cavendish, sure, we had to assume it had to be mass attracts mass, gravity. We just had to assume couldn't be anything else that was doing it. And where's the down in mass attracts mass in Cavendish? There was no down, and it was assumed that it was gravity. It had to be gravity. Cool story. Couldn't have been anything else because we got to keep our fairy tale alive, right? So anyway, number 16. General relativity is a real thing, though it can't be measured and tested. General relativity. 2 expeditions, May 29th, 1919, went to look at a solar eclipse. And they decided they had to move that star behind that solar eclipse. And the boys got together November 6, 1919, the Royal Society. Eddington and the boys pushed through 2 plates out of 36, 2 pictures out of 36, that proved general relativity, the bending and warping of space-time. And Einstein woke up November 7th, 1919, the savior to the ball going around the sun. Bending and warping of space-time, which is general relativity. Cool. We don't see it anywhere, but we had to get rid of Newton and replace him with Einstein, because Einstein was our boy, the big boy. I call mine. And so, hey, it's no problem, man. We can't prove it, but hey, as long as my milk's 110 degrees, I could care less what you guys tell me. You can tell me all the fairy tales you want to. I just want you to know, my milk at 110, I want my blankie, I want my my fan, maybe a cookie or 2, and then I'm good to go, man. You can lie to me all you want to and tell me your fairy tale. I'm cool with that, man. Number 17, E equal HV or E equal HF. And that goes into, segues into number 18. Planck's constant has been measured. What is the H in the E equal HV or E equal HF? H is Planck's constant. 6.626 times 10 to the negative 34. Write that out, folks. 33 zeros, 6626. Planck's constant. I think he started talking about it in late 1900, published a paper on it in 1901, and I think his Nobel Prize was in 1918. Don't hold me to that, might have been 1915. But it's cool. It's a cool story, and some people say that Planck did it out of an act of despair. I can see why it's despair. I mean, my goodness, guys, think about this. 6.626 times 10 to the negative 34.33066626. So the E has to equal H or V. So the E side has to equal the H or V side. So you do that for me. Come back with me. Make sure it's after I finish my milk and my bedtime story. Thanks. Number 19. Electrons can be bumped to another orbit or even back into the nucleus. Photoelectric effect that Einstein stole in 1905, won a Nobel Prize for in 1921. Massless photons. Massless, M-A-S-S-L-E-S-S, photons. Light, we're told, goes into an atom. The atom has electrons going around, and it has a nucleus in the center. And these massless photons bump into electrons and push them into another orbit, maybe back into the nucleus. Who knows where else? Never been seen ever. Not even with an electron microscope has never been seen. But hey, Einstein stole it, so it has to be true, right? Number 20. Massless photons. I like massless photons. I like massless photons in the space-time curvature. Can travel billions upon billions of years in the vacuum of outer space to reach your eye. Those have never been measured. So, I have yet to have a globe believer tell me that this cannot happen. that a massless photon can travel 13.7 billion years with a B, which is 86 trillion 600 quintillion miles with 18 zeros behind that, in order to reach your eye on Earth. Cool. In the vacuum of outer space. 13.7 billion, 86 trillion 600 quintillion miles, 18 zeros behind it to reach your eye through the vacuum of outer space. Cool. Cool. I like it. I'm looking forward to my milk. Thank you. An asteroid or planet named Theia, Theia, 4.5 billion years ago hit the Earth. The Earth at the time was straight up and down, north, south, wasn't like this, up and down like this, and Theia 4.5 billion years ago hit it just right that caused it to tilt at 23.4 degrees, so you could vacation in Florida or move to Florida because of the weather. So I just want you to know that 4.5 billion years ago, large asteroid, small planet, hit the Earth, tilted it 23.4 degrees, vacation in Florida, and then the remainder became the moon. Oh my goodness. Oh, got my milk ready? Okay, not yet. Anyway, then we're going to get to muons, M-U-O-N-S, can use time dilation to make their way to the surface of the Earth. We got these cosmic rays that come down, lots of them. Maybe we'll do another talk on cosmic rays sometime. Maybe not. Anyway, muons are supposed to, they come down really small, lifespan of nothing. And they're supposed to be, gone at 50,000 feet, in the air. But they aren't. Some of them find their way down to the ground. And they find out there's too many muons on the ground. So how did these muons that are supposed to be all gone at 50,000 feet make their way down to sea level, make it down to the ground? It had to be time dilation. God bless time dilation. Muons can make it to the ground. But then they die. Or they turn into electrons, or whatever they want in their fairy tale. I don't care. I got my milk coming, man. Good. And then the last one. 84% of what we don't know, what is called dark matter, is present in the universe to make relativity work in the math. So we have this great big universe out here, an ever-expanding universe, at 4 times the speed of light, but we don't know how big it is. But we don't care, because it's a fairy tale. You can, whatever you want to do in a fairy tale is fine. I want you to know that. So, 84% of what we don't know out in the universe we call dark matter. We put it out there. Don't know what it is, but it makes relativity work. If we put 60% out there, relativity wouldn't work. If we put 97% out there, relativity wouldn't work. But we put 84% out there, and hey, it works, man. And then it might change tomorrow, the next day, the next day. I don't care. I get a bedtime story. I get my milk, get my blanket, get my fan, and I'm just happy. So you go ahead and just lie to me, and I don't care. I just want you to know I do care. And I want to thank you for watching this. Have a great day.